Okay, okay. Good morning to my viewers outside there. This is Citadel of Wisdom Heritage Online School. And in this place, we are here to explain physics practical and other subjects, even physics theoretical concept. But this time around, I've dedicated my time to explain everything about NACO physics practical for 2024. So I have got a lot of comments on my YouTube channel asking me to explain how the pulley can be fixed. You can see the pulley right here. It's very simple to fix the pulley, which I'm going to explain right away. But before I do that, listen to me and listen carefully. I've got something to say about a mistake that must not be made tomorrow. Tomorrow is going to be the physics practical 20 for NACO 2024. And if you want your teacher, your students rather, to get the right answer and the right table, don't you ever make the following mistakes because of the following reasons. Number one, I talked about using this kind of masses. We call it English masses. Look at here. English masses. They are accurate. They are accurate. English masses accurate. Not this type. This one is 5 gram anyway. Not this type. It's not because it's 5 gram. Because of the nature. If you look at it, the texture is rough. These ones will not give you exact values except if confirmed with a weighing balance. You don't just supply masses. You don't just supply resistors. You don't just supply constant wire. You don't just supply pulley. There are important information you must know about the quality of the apparatus or the apparatus or apparatuses for English people that you are supplying. Let's go. Now, don't you ever give them this kind of pulley. I'm going to explain. I believe you can see it. Not because of the shape, I always stress. The shape is not a problem, but I'm going to guide you why you must not give them. And you have to give them this. Look at it. If you look at this, this is a plastic pulley, but this one is a wooden pulley. Now, for this plastic pulley, if you check the groove, that is the opening where the twine or the thread will be inserted, is kind of smooth. What does that tell you? It tells you that it is a frictionless pulley. And if it is a frictionless pulley, the efficiency is 100% because the mechanical advantage will be equal to the velocity ratio. And therefore, the tension in the two ends of the string will be the same, which means there's no external force acting on the pulley. And the masses you hang on the pulley will be the weight of the masses will be the only weight acting on that section of the thread. But if you use this kind of pulley, look at the disadvantage. If you look at the groove here, it's just wood. They just scraped out wood as the groove, and they just insert a bolt and nut, put a frame, and they call it pulley simply because there is a groove and it is rotating. Two things are important here. If you check it here, this place is not smooth. I want you to look at it very well. It's not smooth. Can you see it? Can you see it? It's not smooth. Very rough. Can you see the rough texture? As against this. Can you see this one now? Do you see how smooth it is? Now, these two things are going to give you two different answers. Because the efficiency of this guy is not up to 100%. I had run the analysis with the two of them, and they gave me two different results, which is making me to make this video. Please don't just say I'm to supply. That slope they are calculating, 2 marks can change the destiny of the students. You never can tell. And moreover, table has the highest mark, and if the right values are not in the table, it's going to affect them because of the apparatus. I have argued with physics teachers. I've been doing this thing for 9 years, so I've understood the nitty-gritty of what practical entails. They said electricity does not give the required answer, magnet does not. It's not true. If you give them the right apparatus, if your analysis is top-notch and correct, I promise you, you are going to get the right results. So, okay, the real deal, how do we attach the pulley? Okay. For this kind of pulley, if not because I said you should not use it for obvious reasons, You could just put it here, and that's all. Ensure this guy is firm, right? Ensure it's firm. But since we are not using this, there's no need of me explaining how to fix it. But it's just to insert it. If you have this kind of pulley that you can insert like that, fine. But ensure you fasten it to the wall. You could use many things. You can use two nails to attack the end. Let it not be moving. Because if it is moving, that means every point in time, your thread that comes like this will not be straight. Is that okay? That's all. Now, but you are not using this for two reasons. Now, if you look at it again, the motion is not smooth. It's kind of gyrating. Can you see it? Do you see it? Do you see it? It's gyrating. That means it's not giving you a what? A kind of perfect rotational motion. How do you expect this pulley to work effectively? The tension will not be the same, and it's going to give you a very wrong answer. As against this, if you try this one is better. The rotation here is better. It's better. So that's it. That's why you must use it. Now, how then do we fix this? Very simple. I have my pin here. I can use these two pins to fit it because ordinarily there is what? Can you see a kind of hook here? There is a hook. This hook will help you. There is supposed to be a hook downwards, but that hook has cut because I've exhausted the ones I have because I'm set for tomorrow. But I'm going to fix one end so that you will understand. How do you do it? Very simple. You're going to attach it to the wall with the help of the hook. Just place this guy here. Place the grooves. That's all. You're done. If you don't want to use, you can use this side. You're done. Then you now, if it has the other end, since my own does not have, you fix the other end. You use the second hook and put it here. Put it here, then you attach the other end. That's all. You're done. You're good to go. But ensure it, you see, it's free to rotate. It's free to rotate. It should not be touching the body of what of the board, and it should not be touching the black covering. Please, it must be free to rotate. You see, because that freedom to rotate gives you the frictionless pulley we talked about. Is that okay? Now, having done this, the next thing to do is to ensure the line that is going to come along the pulley is straight. How do you do it? You place your ruler such a way that it is at the same level with the position of the pulley. See now, it's at the same level here, at the same level. Then, not like this, it says that I'm not below. Just directly, just like a tangent on the surface of the pulley, just like a tangent on the surface of the pulley. Then you carefully and gently draw a perfect straight line. You rule a straight line. A straight line. Now, having ruled that straight line, and the end of the straight line, you will carry what? Let me use this one. I remember you're supposed to attach it so that it will firm like this. If the pulley they just cut while I was trying to use it, but I have other ones I've fixed which I will show you. Now, this straight line, you now attach the top pin at the end. Look at this. The reason is this: when I put the thread here, the thread will just run and come down without in a straight line. The straight nature of this line will help you for your thread or twine to what? Align. If you put it here, it's going to form a diagonal line, which is not a perfect thing to do. If you put it above, it's going to come like this, which is not the best. That's why I had placed a metal rule on the surface like a tangent of to a circle, and I draw a what? A horizontal line. Then along that horizontal line, you will now put what? The pin where the twine will be attached before it runs over the pulley. Is that okay? You can keep on extending the line so that the A4 paper can fix inside without touching this word pin. That's all. I believe you understand. Please, I am begging you, don't use this kind of pulley. Don't use it. Don't use it, please. You see, it's not smooth. Can you see the line inside? That line will be holding, you'll be dragging the thread. You'll be dragging the twine. And look at the way it's moving. It's not free. It's not free. Please, don't use it. So please follow me, subscribe, comment, like, share to others. I'll be sharing with you top secrets in physics, and you know physics practical is 35 to 40%. You cannot afford your children not the best. Please, what you give them is the best. Give them the best. When you give them the best, you'll be happy as a teacher. Like I said, I've been doing this for 9 years and my children have been excelling. Now let me take you on a journey as I summarize for you to see that I'm set for today. Okay, this is the one I used to perform the experiment. You could see that I am settled and set for today, for tomorrow rather, for tomorrow. Can you see what I'm talking about? Can you see one hook? Can you see the other one? So I'm set, right? Mhm. And you can see, let me remove so that you see the straight line that is more or less like a tangent. Can you see it? Can you see the straight line now? More or less like a tangent. Can you see it? Can you see it on the surface of the pulley? Where the and see how it's moving? Very free, very free. Okay, so let me remove. This one is touching it. Can you see? Very free. So that's all. This another one. This another board. See, very free to move. Can you see it? So that's a kind of pillow. Can you see the line is running like a tangent, and I fix my pin here. I'll show you another one. See this one too. Okay, there's a mouse attached on this one. See, this one is very free. See. Now for this guy, he doesn't have the second hook. So what did I do? I attach a string and fasten it to the end so that it is firm and it does not move. It's just to improvise because I don't have 10,000 naira to buy first board when I need many in the lab. Is that okay? You can improvise, and it's giving me a fine result. So I'm good to go. This is another one. Can you see another one here? Can you see it here? Can you see it here? Can you see it here? I will still show you again. My children used it yesterday for a mock analysis. So, and in yesterday's practical, I went close to the masses that we are suspecting. So that's a, can you see again the line? Can you see it? Like in tangent, can you see it now? And I attacked here. That's all. It's as simple as this. So I wish you all the best in tomorrow's exam. I wish the students and your students all the best. And my student too, all the best. We will make it together. And you'll always be remembered by your students. And you are learning more on the job. Feel free to ask any question, comment, like, and share. Criticize constructively. Let's work together and change Nigeria, change Africa, and the whole world at large. I still remember I remain Mr. Yusuf Wisdom, a Citadel of Wisdom Heritage School. Thank you so much for being part of my audience.